Hey folks, it's Doug here from Mesh. I hope you're well. Just doing a really quick video on our version 3 of our embodied carbon calculator. We've made a few tweaks and changes which will help you use this to more or a greater effect in your project coming up. The big change for this calculator is that you can look at domestic and commercial embodied carbon targets against RIBA 2030. So that's the big one. There's some subtle ones, and I'll show you on the screen as we go through it some of the other things that have changed. So I'm just going to look at this other screen. I am paying attention really, and we'll take you through some of the changes here. So nothing's changed on the calculator. We've had a kind of a rebrand, hence the new colours. So it actually looks a lot more different than it is. We've had a rebrand on the colour, so there's just an intro as to how to use the calculator. This video I'll actually record and put on YouTube, so down here you can click the YouTube link. And we've got a guideline here as to U values and the kinds of technologies that you want to be putting into the buildings in order to meet those targets. But we've also got some quite handy little Excel tricks that have been coded in to help you without having to take a look at that. And then the final calculator itself, as before, you can have a look at 3 separate buildings, but we'll just focus on one for the minute. So at the start, you can put in your unique kind of building name, call that whatever you want to call it. And now we've got a choice here of being able to choose between domestic and commercial. So when you do that, it picks up the RIBA target. So for example, if we stick with domestic and you want to hit RIBA 2020, it now tells you the embodied carbon threshold for that. So if we improve that to 2030, it's gone down to below 300, and you can look at commercial and that changes it to the relevant number. So if you pick from the project and you pick the target you want to hit, it immediately tells you the threshold that you've got to hit. But rather than scrolling down the page and looking to the bottom where we had the graph before, you can also get a live feedback in this cell here, D10, which gives you the actual live output of the data, so you can immediately see if you're up and below. We kind of held back from doing a kind of a traffic light system. It was all getting a bit crazy, but here you can see a lot of key information and look at domestic and commercial targets. And right at the bottom, we've got the graphs that you can pick up on and see the kind of the breakdown of the elements. We've also frozen these panes. We've frozen the panes at the top and the side, so as you scroll around, you always know what you're filling in. And to save time on this video, we've got some stuff already filled in. And a really cool thing that we've done here, that I think is cool anyway, but it's me that's written it. So what we've got here, I don't know if you saw that, but basically when you choose your RIBA target that you're trying to target, it's likely that you're going to have to improve the building fabric in order to meet that target. In line with the operational efficiency table that we've got here. But to help you guys out, so you're not having to flip-flop between those, as soon as you set this target, we have got, when you look in the automatically calculated U value that you calculate based on the way that the walls and floors and roofs and stuff are built up, it goes green when you've basically hit that target. So you can merrily go in and choose your materials, put in the thicknesses, and you get to a point where when the U value is low enough, the cell turns green. It's a good little visual indicator that you're about there with that element. Of course, you might get some slight variations, but we've done just a little visual tell there as well. So as before on the previous versions, you go through, drop in your materials, drop in the thicknesses, put in the floor area, and it tells you the breakdown of the individual embodied carbon for those materials and the overall embodied carbon for that element. And we've got sheet materials and non-sheet materials. I'm not going to go through all of this from scratch because this is a catch-up video. But one of the other things that we did pick up based on other comments is we've now got 2 different roof types in there. We've got 2 different external wall types you can choose from, 2 different internal wall constructions. So it picks up on some of those subtleties between a building that may have different constructions in it. Now, the other really cool thing we've done is we moved to give you guys some commercial options. There's every chance that you're going to get into multi-story buildings. And so we thought about this problem, and rather than making this calculator really, really difficult, we said that we would allow essentially like a multiplication factor. So for example, if you were building a particular floor to a building, you can multiply that floor up. So the walls, you can build in what's in the walls. You can put in the area of those walls, which might be a single story. In this particular case, the U value is pretty much bang on. It tells you the embodied carbon, but this is the really cool thing. So if you have that story and you say, I've got 5 of these, all you have to do is put in a multiplier of 5 and everything magically amps up and adds those floors on for you. Now, and that's the same for the construction types, internal construction as well. So you do that for the external walls. If you've got the same for the internal walls as well, you've got to put in a multiplier there. Hopefully a lot of this is common sense, but it allows you to save a lot of time here. What we didn't do, and this is really key, is to keep these elements separate, you've got to put in, if you multiply and have 5 stories, you've got to add up the total windows in that development. We decided not to do a windows multiplier. So you've got to bear in mind that when you put in the values for windows, you put in the total for all floors together. I say hopefully it's kind of common sense, but we haven't got a multiplier on the windows. And the ground floor, nothing has changed there particularly. What has changed beyond these multipliers, it's still absolutely critical that you fill in these bright yellow cells, which are the ground floor area. We did have some comments that when people hadn't filled this in, they were getting zeros further up on the table. So worth remembering that you've got to fill in these bright yellow cells to get some meaningful data out. And then just to wrap up here, we have now got 1 or 2 other choices for heating technology. So we've got air source, ground source, gas. We've also dropped in CHP there for more commercial dwellings, or buildings, should I say. We've still got underfloor heating and radiators, and mechanical ventilation or mechanical ventilation are your options. So we've got a couple of extra choices on the heating. And what we've done here as well is we graduate. There is a subtlety as you design for buildings that are closer to RIBA 2030, because the insulation properties of the building is improving, you use less energy and your heating systems can be smaller. So in the background, you'll notice that these values change as you change your targets, because it's assumed the insulation values are getting worse. So we have allowed for that subtlety in there. So as we change between RIBA 2030, if you look at the heating, that's 2,000 kilograms of CO2 for air source. If we change to a higher target, that number reduces because your heating system's smaller. So we've got some variation in there, which gives you a more professional and reliable result. So as you can see here, this particular building is well over on the embodied carbon, but hopefully these changes will really help you improve your early stage embodied carbon calculations. Thanks, guys.